In this video, we will be reviewing over Archimedes' principle. Now, Archimedes was a Greek mathematician, physicist, and engineer that lived more than 2,000 years ago. And Archimedes discovered the relationship between buoyant force and how much fluid is displaced by an object. And he called this Archimedes' principle. And what Archimedes' principle says is that the buoyant force acting on an object in a fluid is equal to the weight of the fluid displaced by the object. Now we can practice figuring out the buoyant force using a beach ball suspended in a pool. Now our beach ball is going to have a volume of 14,130 cubic centimeters, and the weight of the beach ball in air is 1.5 newtons. Now if we put the beach ball in the water and we don't push down on it, you're going to see that the beach ball floats on top of the water by itself, and only a small portion of the beach ball is underwater. Now let's say we measure the volume of the beach ball that is underwater, and we determine that that amount is 153 cubic centimeters. So we'll just say that it's that amount. Now knowing that 1 cubic centimeter of water has a mass of 1 gram, and we'll write that down. We can calculate the weight of the water displaced by the beach ball. So that if we have 153 cubic centimeters of water, that will equal 153 grams, or 0.153 kilograms. And so if we want to determine the weight, we're going to take the mass, which is our 0.153 kilograms, and we're going to multiply that times the force of gravity per kilogram. And if you remember, the force of gravity is 9.8 Newton kilograms. And so when we do our math, we would calculate 1.5 newtons as the weight of our beach ball. And so what this shows is that according to Archimedes' principle, the buoyant force acting on the beach ball equals the weight of the water displaced by the beach ball. And since the beach ball is floating in equilibrium, the weight of the ball pushing down must equal the buoyant force pushing up on the ball. And so we've just shown that each of the weights worked out to be 1.5 newtons. And so the previous example we looked at showed that an object is in static equilibrium and that the upward buoyant force is balanced by the downward force of gravity, and so that the volume of the fluid displaced, previously the example being in water, corresponds to the volume of the object beneath the fluid. In that previous example, that was the beach ball. So as we look at Archimedes' principle, we can see that the buoyant force of a given body will equal the mass times the acceleration due to gravity of the fluid. To get the mass, we have the density times the volume, so that our buoyant force of a given body will equal the density times the volume of the displaced fluid times the acceleration due to gravity. And so that our volume of our object should equal the volume of the fluid. So let's look at an example problem. A ball of mass 2 kilograms having a diameter of 50 centimeters falls into the swimming pool. Calculate its buoyant force and the volume of water displaced. Now let's look at what we were given. First off, the mass of the water will equal 2 kilograms. The diameter of the ball is going to be 0.5 meters, and we change centimeters to the 0.5 meters. And so our radius would be 0.25 meters. To calculate the volume of a sphere, volume equals 4/3 times pi radius cubed. So we would have 4/3 pi times 0.25 cubed, and we would get the volume of the sphere as being 0.0208 meters cubed. Now, the density is given by mass divided by volume, So we have 2 kilograms divided by 0.0208 meters cubed, and so we would have a density of 96 kilograms per meter cubed. Now let's look at calculating the force. The force is given by force equals mass times gravity. And so the buoyant force would be 2 kilograms times the pull of gravity is 9.8 meters per second squared, which would be 19.6 newtons. If we plug that information into Archimedes' formula, remember that force equals density times the acceleration due to gravity times the amount of displaced fluid. And so we plug our information in. If we want to know how much water was displaced, we would take our force, which was our 19.6 newtons. We would divide that by our density, which was 96, and we calculated that right here. And then multiply that times 9.8, which is the acceleration due to gravity, and we would get a volume of 0.0208 meters cubed. And you'll notice that the volume displaced by the water is the same as the volume that we calculated for the ball. And so we can see that the volume of the given body of the ball equals the volume of the displaced liquid. Now here we have a second example. If a stone of mass 250 grams is thrown into the water, calculate the buoyant force acting on it. Well, let's start off with what we're given. We're given the mass of the stone as being 0.25 kilograms. Now we did convert the grams to kilograms. And the buoyant force is given as force equals mass times the acceleration due to gravity. So we have our mass as 0.25 kilograms, our acceleration due to gravity as 9.8. We do the math and we get 2.45 newtons. And so 2.45 newtons of upward force is acting on the stone. Now let's look at one final example of Archimedes' principle. We have a bargain hunter that purchases a golden crown at a flea market. After she gets home, she hangs it from a scale and finds that its weight in air to be 7.84 newtons. She then weighs the crown while it is submerged in water. Now the density of water is going to be 1,000 kilograms per meter cubed. When she does that, the scale reads 6.86 newtons. Is the crown made of pure gold? If the density of gold is 19.3 times 10 to the third kilograms per meter cubed. Now the first thing we need to do is we need to find the buoyant force of our crown. And so to find our buoyant force of our crown, we're going to take the force of the object in air, which was our 7.84 newtons, subtracting the force of the object in water, which is 6.86 newtons. And so we're going to get the buoyant force as being 0.98 newtons. Next we need to find the volume. So we have our buoyant force will equal our density times our displaced volume times our acceleration due to gravity. Now in this case our volume is our unknown. So we will have our buoyant force as being 0.98 newtons. We have the density of water being 1,000 kilograms per meter cubed. Volume is unknown, and with the acceleration of gravity is 9.8. And so when we solve for volume, we get 0.001 meters cubed. And so that's why we have the volume of the fluid as 0.0001 meters cubed. And so we know that the volume of the fluid equals the volume of the object, and so we have the same volume. Next we need to calculate the mass. Now we were told that our weight was 7.84 newtons, and we know that 1 kilogram equals 9.80 newtons. So we take our 7.84 newtons times 1 kilogram over 9.8 newtons. Newtons cancels out, we're in kilograms, and so we get the mass as being 0.80 kilograms, and that's what we have right here. Now, To get the density of our crown, we take our mass divided by volume. So we would take our 0.80 kilograms divided by our volume of 0.0001 meters cubed. And so we would get a density of 8,000 kilograms per meter cubed. Now we'll notice that this right here does not equal the density of gold, therefore the crown is not gold.